All right, before we get to that, let's talk assignments real quick. If it is a worksheet, it should also be blue, which means you can click on it. You can even see exactly what the worksheet is. You lost it, you can download another one. Or if you're not sure what it was, there you go, right? All that stuff has links on it. This right here, A.AIO, that's Albert, right? And that's how you actually get to it. APC, AP Classroom, although somebody last period did tell me that 1.3 to 1.4 was not there on Friday. I didn't know that. Nobody has said that to me. I totally thought I put both of them in there, which maybe I didn't. So if it's not there, it will be there 2 days before I leave, as long as I don't forget. And then DM, what do we think DM means? Delta Math. And you have to get to Delta Math through what? Canvas, yes. So remember, the summer was different because you weren't officially in my class. So we had to go separately and probably use a personal one, all that kind of stuff for the summer assignments. But to get to the Delta Math assignments, you go through Canvas and then click on assignments. You'll see DM-0.1. It'll look, the titles will look exactly the same, so there's no question. Okay, I just want to make sure you understand what to read, how to read this. If you ever don't understand something, just make sure you ask me, because I think after a while it starts to make sense. But I don't want to write everything out. It'll be way too much. I also had somebody tell me earlier today on this quiz, because this is a quiz on 1.4, which we started on Tuesday, and they said, I wasn't here on Tuesday when y'all went over that. I said, okay, I don't know what to tell you, but the video's been on YouTube since last Tuesday, and the papers are right there, and if you're not sure what to do, you ask. You don't wait till the day of the quiz to say, I wasn't here, right? I mean, that rarely happens at y'all's level, but it still sometimes does. So that's on you, not on me. I mean, I'll be happy to help you figure it out, but you can't just never say anything. All right, so let's get started on this. Now, this is going on page 26. Keyword to this is review. This is a review. This was also on your summer assignment. Should I actually have to spend a day or two on this? No, I do it partly out of self-preservation, but also because even those of you that may be very good at this and did your summer assignment, did all that stuff, sometimes hearing it again, or maybe hearing it a little bit different or exactly the same as you have before, can still help you do it well and figure things out. So I think it benefits everybody. Hopefully most of this will seem like a piece of cake to you, because it really should be. All right, so we're going to start very basic with the greatest common factor. And there is a difference between a greatest common factor and a common factor, because sometimes we get the common factor, but it's not the greatest, right? And sometimes that's okay if we're trying to cancel it out. Like if I had this and all I could do, like from a denominator, was cancel out a 2, just factoring out a 2 might be totally enough for me at that point, right? But if I'm trying to actually reduce things to make it easier on myself, we're always looking for the greatest common factor. So just looking at the 24 and 54, what's the biggest number I can factor out of both of those numbers? 6, okay? I heard 8, I've heard 8 all day, and that's okay. Because if that was 56, then I could do an 8. And 54 and 56, I'm not gonna lie, I still have to think about them, or I'm gonna say the wrong one. Although somebody told me not too long ago, and I've been doing this, I mean, obviously been doing multiplication facts a lot longer than y'all, but the 56, that's always 7 and 8, because of 5, 6, 7, 8 makes total sense, and now I can keep it straight in my brain. Plus 5 plus 4 is 9, so that helps me with that one too. You gotta do what you gotta do. But we're gonna factor out a 6. How many y's get to come out? 3. Y cubed, right? So that leaves me with 4y minus what? 9. Okay, GCF, right? All right, 51 and 17. 17 is definitely a prime number. Is 51 a prime number? No, it is not. 5 plus 1 is 6, so it's divisible by 3. And 51 divided by 3 is, you guessed it, 17. So I can factor out a 17. How many A's get to come out? 3. How many B's? 4. Good. So then that leaves me with 3 times A to the 5th, no B's, plus the 17's gone, all the A's are gone, I'm just left with 1 B right there. Okay, we good on that? All right, so now before we talk about just basic factoring of trinomials and stuff, we're going to talk about some of the special cases first. This first one is comes up a lot, and in my opinion, probably the easiest one there is, but you got to be able to recognize it. You also got to know your perfect squares. So your perfect squares are 1, 4, 9, 16, 25, 36, and so on. Knowing your perfect squares to 25, not that 25, but 25 squared, which is 625, will help you a lot. One of the biggest hurdles to factoring is your multiplication facts. And way too many of you don't know your multiplication facts, and that's what makes some of this so difficult. And that's not anything I can help you with. That's something you got to figure out on your own. All right, so what the rule for difference of squares is, a squared minus b squared. So literally, if you have two perfect squares that are being subtracted, that is a difference of squares. How to factor it? Super simple. Looks like this. You factor this into two binomials, where it becomes a plus b times a minus b. Okay? That's it. And this, like I said, it comes up a lot. It's easy, but you got to know what to do. So when we look here, we've got 36w squared minus 25. Both of those are perfect squares. So I'm going to get two binomials, one with a plus, one with a minus. What's the square root of 36w squared? 6w. Good. 6w. And the square root of 25? 5. So it's 6w plus 5, 6w minus 5, and we're done. Okay? Doesn't really get that much easier than that. But if you don't know the rule, it doesn't matter how easy it is because you don't know the rule. Right? Now 4 looks a little bit yuckier, but we still got to recognize it as a perfect square. And what is the square root of 1 over 44? 1 over 12, exactly. And then when you are taking the square root of things with variables, if the variables all have even exponents, it's super easy. All you do is take the exponents and divide them by 2. So this would be r cubed s squared. And then this would be 1 over 12 minus r cubed s squared. Okay. Now, when I say it comes up a lot, it actually comes up a lot in an easier fashion, meaning like if I just have x squared minus 49, that's a super easy one, right? That's going to be x plus what? 7x minus 7. So we'll get something this simple way more often than either of the others, but having a coefficient here, that's not unheard of. And this will show up every now and then. You just can't freak out, and you need to recognize it as a perfect square. Okay? We good so far? Any questions? All looks familiar, right? Just knocking some cobwebs off. All right, so notice we have a difference of squares. There is no sum of squares. So if you have x squared plus 49, nothing you can do with it, all right? But for the cubes, we have sum and difference of cubes, okay? We have them both. And your perfect cubes look like this, like 1, 8, 27, 64, 125, 216. Knowing up to that is probably good enough, and then just being able to figure out the rest, like recognizing them. You know, sometimes just recognizing that it's a perfect cube, that helps you a lot in determining what the cube root actually is. But here's our rule for factoring. And sum of cubes and difference of cubes are very, very similar. So we're going to talk about them together because I think that that is helpful here. So your factoring, if I have, so sum of cubes, that would be like a cubed plus b cubed, right? And difference would be a cubed minus b cubed. Okay? Got a perfect cube and a perfect cube. You're either adding them or subtracting them. In both cases, when you factor them, you will end up with a binomial times a trinomial. Binomial times a trinomial. And then the rule for, or the pattern rather, for getting the variables and the numbers inside of here, like we're not going to worry about the signs in between things yet, just getting the terms in there. You're going to take the cube root of the first one and the cube root of the second one. Those are the two terms for your little binomial. That's true for both A and B. Okay. Then the way you get the trinomial, you take this first one, whatever it is, and you square it. So there's a squared. The middle term is the two multiplied together, A times B. And then the last one is the second one squared. See how easy that pattern is? Okay, it's really not that bad. And it's exactly the same if you have difference. A squared, A times B, B squared. Okay. The signs in between there, whether they're plus or minus, that's what's different for the two. And there's an acronym to help you with that. Can anybody tell me what that is? That's something you wash with? SOAP. Okay. If you've never heard SOAP, I'm about to change your life because it's going to make this super easy. Doesn't do any good just to know SOAP if you don't know what SOAP stands for. It stands for same, opposite, always positive. Right? Same, opposite, always positive. So if I have a sum of cubes and then I can get everything laid out like I have so far, then since this is the sum, my first sign is the same, second one is the opposite, the last one, always positive. Okay? Same goes for difference. This is a difference, so same, opposite, always positive. Okay? You see how the rules are kind of the same? They're the same, so I don't want you to think about them as two completely different rules because they're really not. It's the same pattern for filling stuff in, and then we put the signs in. That's how I factor it too, because these don't come up a whole lot, but when they do, we have to know what to do with them. So you have to have a way to get it out of that filing cabinet in your brain, right? So let's try this one. I have a sum of cubes here, so I'm going to have a binomial and a trinomial. And this is exactly what I would do for myself if I was doing this. I take the cube root of h cubed, that's h. What's the cube root of 125? 5, okay? Then first term here is going to be h squared. Second term, I multiply them together, so it's 5 times h. Last one is 5 squared, which is 25. Okay, so I lay all that out. Then I think of SOAP. This was the sum, so this is same, opposite, always positive. See how easy that is? If you know the pattern and the rules. If you don't know the pattern and the rules, then yeah, it's really hard. But find a way to make that make sense to you that you can keep that in your brain, okay? Now, sometimes we have coefficients. Look at number 8. So I'm still going to have a binomial and a trinomial. Sometimes I don't leave myself enough room. So cube root of 8f cubed, what would that be? 2f. So I have 2f here. Cube root of 27, 3. Okay. So now I have to be careful. When I go and put this term in here, I have to take this term and square it. That means that is 2f times 2f. And what is that? 4f squared. Make sure that you don't just put the square on the variable, right? You're squaring the entire thing. The middle term, I multiply these two together. So 2f times 3 is 6f. Then I square the 3 and I get 9. Then put your signs in there. Same, opposite, always positive. Okay? Any questions at this point? We good? All right. So then let's do this one. Difference of cubes. Well, we're going to start the same way. Binomial, trinomial. Cube root of x cubed is x. Can anybody tell me the cube root of 343? 7. Okay, so earlier today I heard 13 because they didn't know, so they were taking a wild guess. That's what we have to do sometimes, right? So here's what I want you to think about. If you're thinking it's 13 or whatever you think it might be, the 13 times 13, we should know that that is 169. Well, that by itself, if I take that and multiply it by another 13, just multiplying it by 10, it's going to be like 1,600. So that tells me 13 is way too big. So do I want to try 12 or even 11? No, I want to back it down some more, right? So just make sure you're using, your brain when you're doing that kind of stuff. But it is 7. So then that means, well, then you should be able to finish this one up. You finish that one up. And then we're going to do 12 together for sure. Remember what the signs think. Same, opposite, always positive. Any questions on 11? We good? All right. So on 12, before you get ahead of me here, we're going to have a binomial and a trinomial. Now, I know we all feel a little bit more comfortable, maybe not all of us, most of us probably, if our variables come first. But do not go willy-nilly switching things around because it can really affect your signs. Also, don't be overthinking your signs. When you're putting the stuff in here, I know that that's minus, and I know that's like a -7, but that doesn't mean that it's going to be -7 times x to put that here. Like if you waited till the end to put your signs in there, they're not even there for you to make that mistake, right? Because sometimes people overthink it and try to do weird things. Put all the little factors in there, or the terms in there, then put the signs in there so you're getting yourself mixed up. All right, so even though I would like my variables to be first, my opinion doesn't matter, right? So I have to leave them in the order I see them. The cube root of 125 is 5. What's the cube root of 8v cubed? 2v, right? But I'm not going to put a negative there because you're right, it is a -2v, but I'm ignoring all the signs right now so I don't overthink and do something weird. But I'm not putting the 2v first just because I prefer it that way. I leave it like that. And then 5 squared is 25. 2v times 5 is 10v. And then what is 2v squared? 4v squared, right? Now I go put my signs in there. Same, opposite, always positive. Okay. And unless you have a very complex original cubes thing, then your trinomial here doesn't factor. If it's this compound that it has extra stuff in it, it is possible most of the time, but most of the time we don't even need to worry about it. Okay. Questions on any of that? All right, we're going to stop here. So if you get started on the delta math, only work through this stuff. Don't do the other stuff yet until we talk about it, okay?